Alrighty. I'm going to slide up here. We're going to kind of talk about these two at the same time. Ready? Okay. We're going to talk about positive correlation and negative correlation. Have you ever heard those words before? If you've seen these kind of graphs before? Yes, no, maybe? Yes. These are scatter plots. You're plotting data set. If they generally go up like this, it's just like a line. Is that positive or negative, do you think? Positive. If they generally go down, what do you think it is? Negative. Of course, there's really good words to explain that, so we're going to use some different words. We're going to say, as x gets bigger, so does y. How's that for a mathematical explanation? I'm going to show you what I mean here in a second. As x gets bigger, so does y. Because, I'll wait till everybody's done drawing. If you look at this one here, the x coordinates are getting bigger, aren't they, as we go from left to right, correct? Yeah. And at the same time, your y coordinates are getting bigger as well. That causes a positive correlation. As x gets bigger, y gets bigger. Make sense? So how do you think I could write negative correlation then? As x gets bigger, what happens? What happens to the y as x gets bigger if it's a negative? What happens to your y coordinates? They get smaller, don't they? As x gets bigger, like here, y is really big, it's 80. Here, y is only about 60. So as x gets bigger, y gets smaller. That causes a downward motion. No correlation is when the points are all over. Points are all over. You can't really see a positive or negative. Can't see a positive or a negative. Points are all over. Okay, line of fit or line of best fit. Have you ever heard that before? Maybe, maybe not, I'm not sure. All it is you're drawing a line you can use for estimation through the data points. So you're drawing a line you can use for estimation through the data points. You can take that out of here. All right. So let's use some of this stuff. Predict a reasonable test score for 4.5 hours of studying and 4.5 hours of TV watched. Draw a line of fit. There should be approximately as many points above the line as below it. So you're going to look. This is going up, right? I want you to draw a line of fit. Try and get, yours might be slightly different than mine. Just try and get as many points above as below. So you're going to try and go exactly through, mine's a little crooked, through that data. Did he say a bad word? I thought he did. Okay. So, generally this is going which direction? Positive or negative? It's a positive correlation. Positive. Positive correlation. Write that down. Now, it says estimate your test score at 4.5 hours of studying. The reason you draw a line is you go over here to 4.5 hours. So here's 5, so 4.5 is going to be about here. And you go up to your line, and then you use that line to go over to the axis that has test scores, And you could estimate you'd get about a 73% with 4.5 hours of studying. And that's the beauty of the line of best fit. You can use it for estimation. Okay, let's draw a line through here as close as you can. Is that a positive or a negative correlation?
Negative.
Negative. And I find these two pieces, well, you'll see in a second. Let's see. 4.5 hours of TV watched. Let's see what happens to the test score. So I'm going to go here to 4.5, go up to my line, and go over. What? It's saying I'm going to get about a 74%? What? It's saying if you study the same amount as the hours of TV you watch, you get the same grade. I think there's something wrong with that data. Just me. But, makes sense? All right, turn it over. Okay, so describe the correlation of the data graphed in the scatter plot. If possible, draw a line of fit. Okay, so a lot of you just want to say, okay, it's negative. But guess what? You can use so many more words to describe that. Let me show you what you do. Ready? First of all, you look at the X and Y axis. This represents minutes on the treadmill. This represents ounces of water in a water bottle. So you could say in words, the more minutes on the treadmill, what? The more water you use or the less water I have, right? Yes, okay? So that's what it means to describe it, really. It's like the more minutes on the treadmill, the less ounces of water left. Okay? All right, can we draw a line of best fit through there? Sure. Try and draw your best line of fit through. Sometimes you end up with a few more under than above, but do your best. All right. So this is definitely a positive. But we can use so many more words to describe that. X-axis is minutes on the treadmill. Y-axis is calories burned. So in words, what could you say about that correlation? Courtney? Right on. More minutes on the treadmill. Okay. Stay with me. Oh, you're reading? Okay. On treadmill, the more calories burned. Okay, so we draw a line through here. Somebody's not happy or really happy, one or the other. Okay, the only thing I don't like about these notes is that they don't show you a no correlation graph. So far we've only had positive and negative. Okay, so here, we're going to do a little bit of work here. Can't be that easy, can it, the whole thing? Of course not. All right, the table shows the number of injured birds. I don't know where they come up with this stuff. A person rehabilitated at a veterinary service. Write an equation that models the number of rehabilitated birds as a function of the number of years since 1995. So this is year zero. Year zero. So look at our X and Y axis here. Do you see any 1990 anything here? No. We're talking about years and number of birds. So that means I got to write this like this. 1995 is year zero. This is my X, this is my Y. If 1995 is my year 0, 1997 is year what? How many years since 95? 2. 98 is 3 years since 95. 4, 5, 6, 7, 8. That's what I'm going to use for an x-coordinate. So that means that my ordered pair, so instead of using this, I'm going to use 2, 8, 3, 11, 4, 12. Do you see where I'm getting these? 97. So over here, I want you to take a minute to very carefully plot those points as close as you can think where they should be. Okay? Okay. Yours might be a little different than mine. I know that's the way it is. So what is our direction here? We have to write an equation of a line that models the number of birds rehabilitated. So we have a line here. You have the skills to come up with the equation of that line. That's what we've been doing a lot of this semester. Remember, y equals mx plus b, correct? Yeah. What two things do you need out of y equals mx plus b to write an equation of a line? M and b. Slope and y-intercept. So, I also need 2 points, though. So, you need to, here's where kids get confused. They grab 2 points off of here. Because if you were to grab this point and this point, that's a line like that. And that is not our line of best fit, is it? So what you need to do is you need to look at the line that you drew and find 2 points on that line. It might not necessarily be one of these points. You got to look at your graph and say, oh, wait a minute, I actually do have 2 points that went through the line by chance on this one. If I didn't, maybe I could use this point right here, which I know is exactly 820. I know this is exactly 820. So I'm just going to choose 2 points. I'm going to use this point right here because I know it's exactly 820, and it's exactly on my line that I need to find the equation to. Yeah? Then I'm going to pick another point. I need another point. I'll use this one. It is one of my data points, but it seems to work. It's 311. Again, you're picking 2 points that are on your line as close as you can. Okay? All right. I put the directions here because I'm a direction follower. Plot the points and draw the line of best fit. Pick 2 points on the line of best fit. Don't just grab 2 points out of your table. It's not going to work. Okay? You look at your line and you say, can I get 2 points off of there? And I chose 311 and 820. For me, those are the 2 that worked. Find the slope of those 2 points. Oh, that means I go change in y, so I'm going to do 11 minus 20 over change in x, 3 minus 5. I'm going to have a nasty fraction. Yeah. It doesn't matter. We can do it either way. I'm just subtracting my y's, or I can do 20 minus 11 over 8 minus 3. You get the same answer. Yeah, 5 minus 3. No, because I chose this line, which I decided, see, again, I could see that this was exactly 820 at this intersection here, so I chose that because it's on my line. It's not necessarily one of my data points, but that's okay. This is going to be kind of yucky because I'm going to get a fraction. Let's just cheat for sake and make it 4.5. We'll use 4.5. All right. Remember, you need m and b to write the equation of a line. I have m right here, don't I? This equals m. That's my slope. I still need b. plug the slope and one of the points into y equals mx plus b. You've done this before. Does anybody remember doing this? The slope and one of the points into y equals mx plus b. I'm just going to choose this point right here. And I have my slope here. Slope and one of the points. Yeah.
Where did you get the 5 from?
I don't know where I got the 5. Where did I get the 5? This is supposed to be an 8. You're right. See, I'm not thinking very good either. So it should be 9 over 5, shouldn't it, Garrett? What does that equal as a decimal? Does anybody have a calculator or phone or anything they can use? I don't have a calculator up here. What's 9 divided by 5? 1.8. Let's use that. Thank you. That makes more sense. Sorry about that. Thank you, Garrett. Always ask. My brain's been on vacation too. Okay. So I'm going to use the slope and one of my points. Now remember, this is x and this is y, isn't it? That's x, that's y. So I'm going to plug in my y, my m, my x, and I'm going to find b. So it's going to look like this. My y is 11, my slope is 1.8, my x is 3 plus b. I need a calculator. All right, so what do I do now? You guys can't stop talking on the couch. You don't get to sit on the couch. Okay? All right, so 1.8 times 3 is 5.4. Subtract 5.4 from 11. Oh, so I got my b and I have my m. Now I can write the equation of the line. Substitute m and b into y equals mx plus b. Y equals 1.8x plus 5.6. Sweet. I have the equation of the line. Y equals 1.8x plus 5.6. That's the equation of that line. And guess what? Just for the heck of it, we're going to do a little something. You ready? If I have this equation, and I want to know in 2008 how many birds they had, I can use this equation to project how many birds or estimate how many birds they rehabilitated by 2008. If I'm adding 5 more years, my x is actually going to be 13, isn't it? Do you see that? I went from 2003 to 2008. I add 5 more years, so my x is 13. So I'm going to plug that into this equation. Y equals 1.5 times 13 plus 5.6. Yeah, you should write it down because you might have to do this. 29. Y equals 29. So in 2008, I can use my equation to estimate that they'll have 29 birds rehabilitated by 2008. So that's how you use it.